Hi everybody, welcome to Chapter 6. So what we're going to do in Chapter 6 is basically look at some of the same things we did in Chapter 5, risk and returns, right? But now we're going to apply them to a portfolio. And what that will allow us to do is we'll look at something called modern portfolio theory, and that basically uses the mathematics behind portfolios, returns, and risk to create kind of an optimal portfolio that we should invest in. So we're going to start off with this equation, and right here, and what this equation shows us is how to calculate the returns for a portfolio. It's pretty basic. It's basically the weighted average of the returns of the different securities in our portfolio, and this specifically is for two assets. And the W here, right? This is just the weighted average or the percent that we have invested of our portfolio. So it's somewhere between 0 and 100%. And then the weighted average for the other asset too is going to be basically kind of 1 minus that. So what I mean by that, if we have 50% of our portfolio invested in security 1, that must mean we have 50% in the other one too. That's for a 2-asset portfolio. So those W's always have to add up to 1 or 100%. And with a 2-asset portfolio, it's really easy to figure out both of them if you have one then, right? This is how we calculate risk or variance for a 2-asset portfolio. And again, we're going to go through the 2-asset portfolio, and I'll kind of generalize it a little for more assets, but it gets pretty complicated fast with risk. So we're just going to stick with 2 right now. So, some of the terms are the same as what we saw before. The W's are the weights or percent we have invested in each one. And this Greek letter S or sigma, lowercase, is standard deviation. But when you square it, it becomes variance, right? And so the variance for a portfolio, sigma p squared, is the sum of the weights times the variance for the individual securities, plus this last term, which is 2 times the individual weights multiplied by this term, covariance. Covariance, it can be it's derived mathematically. It's basically the variation between how 2 assets move together, right? With variance, you're looking at how a security moves with respect to its mean, up and down, right? Difference in its mean. With covariance, you're looking at the difference between how the 2 securities move together. So that's how we calculate the variance of a portfolio. It's the individual contributions from each security, how risky they are, but then also how the 2 move together. Now, one of the things that we do is we try to simplify this, and one way to simplify it is to take this covariance term that we just talked about. That was right here, right? And we're going to substitute in for it with a term that's a little easier to understand. And that term is this right here. This P is a Greek letter. I guess it's R. Yeah, it's called rho, and it stands for the correlation coefficient. And so it's kind of like covariance, and it's how 2 securities move together. But mathematically, it's actually a number between -1 and 1. And what that makes it is it's easy to understand how 2 stocks move together. If I tell you, oh, these two stocks have a correlation coefficient of -1, you know they move in perfectly opposite directions all the time. If I tell you these 2 stocks have a correlation coefficient of +1, that means they're always moving in perfectly the same direction. Okay? And so that makes it a little easier to understand than this weird number covariance. And then you multiply the correlation coefficient by the individual standard deviations, and that gives you covariance. So the equation that we actually use up more to calculate portfolio variance is this one I just highlighted with the correlation coefficient substituted in. So why don't we do this? Also, let me note, everybody, that if you go to the bottom of your slides, don't forget I've got some extra notes and comments in there, and that's for people who have trouble. If you're not good at watching videos, check out the extra comments down here, and I try to repeat basically the same thing that I'm doing in the video. All right, let's take a look at an example here in calculating how we calculate the portfolio return and the portfolio risk. Okay, that's what this example is going to be about. So here's the setup. Assume we have Microsoft with an expected return of a portfolio of 20% and a standard deviation of 30%, and then we have GE has an expected return in the future of 10% and a standard deviation of 20. And the correlation coefficient between the two is 30%. Calculate the return of the portfolio and the standard deviation if you invest $80 in Microsoft and $20 in GE. So first off, let me just explain a couple things. Since you're putting $80 in Microsoft and 20 in GE, only those two things, you're investing a total of $100, right? And Microsoft is going to be 80% of that because it's $80 out of 100. So that's why when we look up at the weights here, you have 80% of Microsoft. Now, if Microsoft is 80%, without even doing the math on GE, you know it has to be 20% because it's the rest of that 100% portfolio. And so GE is going to be 20%. All right, and this right here, mean, well, it's the expected return for a stock. This goes back a little, maybe last chapter or so, is going to be the historical average or mean. So that's where that comes from. That's what this is right here, right? E with parentheses around it just means what we expect to happen for the return. And for this, we're just using the historical mean for the expectation. And so we're given Microsoft is 20%, right? And GE is 10%. That's given. We're also given the standard deviations for these two, 30% and 20%, right? So why don't we do this? Let's go ahead and calculate the return on the portfolio, and then we're going to go ahead and calculate the return, the standard deviation of the portfolio. So I would suggest you use you pause the video, use the equations that we covered, and do it yourself, or you can keep playing, and we'll take a look at the solution together here. Okay, what I'm going to do here is I'm going to pull up the bottom, the solutions. And so this right here is the equation we're going to use. Right? That's for portfolio return when you have two assets. And we know that W1 is 80% because out of $80, we invested 80 in Microsoft and a total in our portfolio of 100. One of the things we like to do, right, is if we add $80 in one stock, it must be $20 in the other. And you can do that here, right? But if we substitute in right here 0.8, right, then we know it's going to be 0.2 for GE. We could have calculated it mathematically, but sometimes you may not have that much information. You got to make use of this little way of calculating the other weight by just subtracting everything else from one, and then what you're left with is how much you invest in your other security. So if we plug the numbers in, 80%, right, invested in Microsoft with a 20% return, and 20% invested in GE with a 10% return, you get 18%. So 18% is our answer for the expected portfolio return. Now for risk, what we're going to do is we're going to take the square root of that equation that we did before of portfolio risk or variance, right? And so if we take the square root of variance, we get standard deviation. And so this is the variance equation right here with all the numbers plugged in. And if we take the square root of that, it gets us the standard deviation. Okay, so so 0.8 is W, or how much we have invested in Microsoft, what percent, and 0.3 was the standard deviation of Microsoft. We had 20%, which was W on GE, and the standard deviation GE was 20%. So that's what this term is right here. And then this term right here is going to be 2 times the weights, meaning weight of Microsoft 0.8 and the weight of GE, which is 0.2, multiplied by the correlation coefficient, which was 0.3, that was given, and then multiply the individual standard deviations, 30% and 20%. So you multiply all that together, you take the square root, and you get 0.25487. And this is how you would put it into Excel right here. You know, you just equal, and then the SQRT for square root, and then this is how you would mathematically program it into Excel. Okay? So those two numbers that we just calculated, it was around I think 25% right here, right? And then the return was more like I think it was 18%, and so that's right around here. So the portfolio that we just calculated, which was 80% Microsoft, 20% GE, would be somewhere right around here on the on this chart. Microsoft right here lines up at 30% standard deviation and 20% returns. GE lines up at 20% standard deviation and 10% return, right? And my point here is I want to show you that you would think when we combine Microsoft and GE into a portfolio that that point would be maybe on like a straight line in between the Microsoft and GE on this chart. But it turns out it's not. When we plot it right here, right, it's actually kind of to the left a little of a straight line between GE and Microsoft. And so that's pretty important because what it's like physically showing is that when you combine two stocks, the chart where the point lines up on this chart is actually to the left. And if you look, the scale from left to right is risk or standard deviation. And when you move to the left, you reduce risk. So combining these two stocks, it wasn't like a linear combination of the two in terms of a line between GE and Microsoft. It actually moved to the left a little, which reduced risk. Why don't we let's look at two extremes on the possible combinations of these two stocks. And the extremes I'm going to talk about are what happens if the correlation coefficient is -1. That means the stocks move in opposite directions. And the correlation coefficient is +1, meaning they work perfectly together. In fact, this right here should be -1. Sorry about that. All right, so let's take a look at what we get. I'll spare you some of the mathematics. It shows you right down here with a correlation coefficient of -1, I'm only calculating risk because remember, the return portfolio equation doesn't have correlation coefficient in it. Okay? It's only in the risk equation. And so you do the math when the correlation coefficient -1, and you get a risk of 0.2, a standard deviation risk. And that's a lot lower. If the correlation coefficient is +1, we get 0.28. So what does that mean on the chart over here? Let's check it out. So on this chart, you see here, when we have rho or correlation coefficient equal to 1, it puts a dot right here. If we have correlation coefficient -1, it's going to be way out here. And if we draw a line between Microsoft and GE that goes through the correlation coefficient for each of these, we're going to get these 3 dark lines. And you notice with correlation coefficient of 1, it's linear. Well, it turns out if 2 things are perfectly correlated, you get no risk reduction when you build a portfolio. That's why it's a straight line. It doesn't go to the left at all. If you have a less than 1 correlation coefficient, you get a little risk reduction. And so this curve here, which represents all the different possible combinations we have of GE and Microsoft, right? Like down here would be 90% GE. This further up here, this would be maybe 10% GE. But all those combinations of portfolios are moving to the left because we're reducing risk because of this lower correlation coefficient. And the lowest you can go is a correlation coefficient -1. And so that means they kind of like cancel each other out when you combine GE and Microsoft. And if you have a portfolio that's 50% of each, look at this. The risk goes to 0 because they're perfectly canceling each other out. They're always moving in opposite direction when you have 50-50 for your portfolio. And so these 3 lines are kind of the bounds of where risk for a portfolio could go. And again, the lines and the curves represent all the possible combinations of GE and Microsoft for a given level of correlation coefficient between the 2. This is what the equations look like for returns and variance when we have more than 2 assets. And this one for return, it's just a summation sign, and that just means that for every stock we have, we add 1 more term, which is the percentage of that portfolio invested in that stock times the return. So that return equation that we did way up here, this one, right? We just add another term every time we add another stock, right? So this would be like W3 times R3 or something like that, right? And you just keep doing that. You just keep adding more and more of those securities. But down here, this term, it gets pretty nasty. And the reason it gets pretty nasty, you got 2 summation signs. So that means every time you add another security in your portfolio, you're going to get a term that is related to how much risk is in that individual security. So the weight squared times the standard deviation of that security squared. And then you've got this thing over here, which represents how your security is covaries or correlated to every other security. So if you add 1 security to a portfolio that has 2 securities, you're going to have an extra 2 terms here. So when you add a security, all right, the number of more terms in your equation depends on how many securities are already in your portfolio. And it becomes basically like a big matrix, a square, and the number of terms in your so like something with like 10 stocks might have a total of 100 terms because it's like a matrix is the way we kind of visualize this. You're not going to be responsible for these, so I'm going to move on. This is what it looks like for a 3-asset portfolio. And you can see here we've got 3 terms for each, but then also when we add how that security co-varies with all the other ones, we start getting a whole mess of terms. The net result of this, when you add more securities to your portfolio, it reduces risk. The more portfolios you add, the more risk gets reduced to a point. So in this slide right here, in the vertical axis, we have portfolio standard deviation. So think of that as risk. And on the right, we basically have the number of stocks in our portfolio. And so in the U.S. markets, there's something like 2,000 some stocks. And so imagine if we have one average stock, we've got a standard deviation of 50%. But once we get to about 20 stocks, that standard deviation goes down to the low 20s. But then it kind of flattens out. And the reason it flattens out, because, just imagine if you own every stock in the stock market, right? You're going to have the same risk as the stock market, and adding one more stock doesn't really reduce your risk that much. So where this pink line flattens out is basically market risk. The part here under the pink curve that gets reduced is what we call unique risk. And so if you own one stock, you're kind of up here at the very top left, and you have a lot of unique risk. But as you build a portfolio that's diversified, the risk that any one stock, something unique happening to any one stock is going to hurt your portfolio becomes small. Because, think about it. If something bad might happen to one of your stocks in your portfolio, there's a chance something good may happen to another stock, and they might cancel each other out. And so unique risk is what we're trying to get rid of when we diversify a portfolio. The market risk we cannot get rid of. That's why it's called sometimes non-diversifiable risk. Because we can't remove it just by buying more stocks. It's always there. It's the market risk.